Hello all, welcome to Samya's Tech Talks. In today's lecture in Advanced C Programming tutorial, we will discuss on structures and bit fields. So in today's lecture, we will cover below topics. So introduction to bit fields, advantages, limitations, and we will see the best practices to use bit fields. We also discuss all this with some sample programs. Let's continue. In general, bit fields are used along with the structures in C programming. So where using bit fields, so you can create a members of structure with size specified in bits. Like you can specify how many bits that member can occupy instead of primitive data types. The primitive data types will take, let's say integer is there, it will take 32 bits, character will take 8 bits, 1 byte, short will take 16 bit, means 2 bytes. But if you use inside the structure, so using bit fields, instead of size in bytes or the actual size of data type, you can tell how many bits you are really going to use. So only that much memory will be allocated, so that it will be used in embedded systems. When you are writing firmware for embedded systems, let's say for example you are accessing the registers. So in general, registers are 32 bit or 64 bit, but they have like each bit will have different meaning. Like bit 0 will have different meaning, so it indicates certain properties of the your MCU microcontroller system. Like that, if you want to access individual bits of the register or group of bits of register, you can use the bit fields. So here for example, you see there is a control register of 32 bit. So bit 0 will tell enable something is enabled or disabled, and bit 1 will tell whether reset happened, that is it is going to reset, or interrupt enable, like interrupts are enabled, bit 2 will tell this. And if you see mode is 4 bits, like it can be different modes of like sleep mode, you can lot of modes. So in general, the meaning the what this control register, the meaning of each bit will be in your data sheet. Okay, if you are using ARM architecture, Intel architecture, or you using some microcontroller, okay, or development board, the data sheet will tell these registers, each bit or group of bit, what is the meaning, what it indicates. So to access this, let's say you are writing a firmware for some particular ARM or architecture or particular microcontroller. So to access these kind of registers, bit fields are convenient to access these registers instead of doing lot of bit operations and maskings and everything. So using bit fields, you can easily do that. We'll see how to achieve this. So for example, for the control register, I defined a structure with bit fields. So here bit field means you will have a member like regular member like structure, but you have a column and tell how many bits this will occupy, it needs. So enable will use only 1 bit, reset will be using 1 bit, interrupt enable is 1 bit, mode is 4 bit, and 25 bits are unused. Okay. So like this you can specify using this syntax, you can specify how many bits. So while accessing also, see in this sample program, I simply access very simply. Instead of when I am setting some bit in the register, I just call control register dot enable equals to 1, disable enable equals to 0. When I disable mode, I can change with some mode using, instead of doing lot of bit operations and masking. So you can easily do this. Okay, so we will see how, if bit fields are not there, same program will be like this. So you will use the primitive unsigned int 32 bit for that register, and this is the address of memory mapped address of that register. So you are creating a pointer which is pointing to this memory mapped address of that particular register. This you will find it in your data sheet. So this is not scope of this lecture. So this is the memory mapper register, and I am creating pointer to that particular register, and I have some variables for masking and bit operation. So to enable and everything, you have to do the bit operations like masking and everything. You can see how that set enable I am doing using the bit operation. So here the code is very complex and not readable, but if you use Bitfields, it's very easy to understand what is happening. So it is very convenient way using the Bitfields instead of this masking and bit operations. Now we will see the advantages of Bitfields. You see, the compiler will take care of your bit operations. Like you will just write a simple C instruction like controller.enable equals to 1, and the behind the compiler will generate. So instead of you do this bit operation, the compiler will generate assembly instructions for that. Okay, and the code is very readable. Okay, and the size of the struct will be optimum, because instead of using primitive data types, even though you don't use the bits, the memory is allocated, so you can pack the your data specifying the size in bits, so that it will take very limited memory and the memory will be saved. Okay, you can also avoid the padding if you properly organize the members, like lowest size to highest size, highest size to lowest size you can organize. You can also avoid the paddings. So these are some advantages. So we will see the disadvantages. So limitations are, one is Indianness. So Indianness, we also did some lecture on this Indianness in our previous lectures. Okay, so Indianness is nothing but the order of saving, the how the if you have a structure with multi bytes, like the structure is of size of multiple bytes, like 4 bytes, 6 bytes. So the order of how it's saved inside the memory, so whether the least significant byte is stored first or most significant byte is stored first, based on that the order of storage inside the memory will be different. Okay, so due to that, if you are using Bitfields, if you are using this structure with Bitfields within your system, you are not transferring to other peripherals or not transferring over network, it is okay. But if you are transferring over network, so in between different systems whose NDNS is different, then it's a problem. So the byte order is reversed and your bits are reversed, and it gives lot of issues. You can refer our previous sessions about these problems. So this is one problem with Bitfields NDNS. And also the non-atomic writes. So non-atomic means, as you are doing read or write using a single C instruction, but the compiler generates lot of instructions for that. So while executing all that instruction, any interrupt happens or something else happens in the system, which leads to change the registers values to something like resetting or setting to different one. So your ultimate operations, the result what you are doing may be unpredictable or inconsistent. So this is called non-atomic. Non-atomic means you take a variable or data where you want to do lot of operations, but in between some other thread or some other task change that value, you are not aware of that. So your ultimate result is not consistent or wrong. So due to this, instead of this, what we can do, so if you are using take the register value to a temporary variable and you do all operations on the temporary variable, and then save the final result, which is atomic, because so you are not you are saving the result once your complete operations are completed, which gives the atomic behavior. Okay, and also complexity, like sometime the compilers generated instructions are not optimized, which gives a lot of issues, like the execution time will be more. Okay, so you have to see whether the compiler instructions are optimum or not. If not, you can use, instead of structures with Bitfields, you can use primitive data types only, and to read and write you can use bitwise operators, shifting and masking, to achieve the same result. So these are limitations. So there are some guidelines are there, so which uh, one is don't use Bitfields only to save memory. Like you might think that if I use Bitfields, so I can define the data members of the struct in bits, size of bits, so that it will save the memory. Don't use that. So also you have to see that how many instructions are generated for this read and write of these bit fields, okay, and whether they are efficient or not. And the bit fields are only suitable when you are accessing the system registers. When you are writing embedded firmware where you want to read write to system register, bit fields are very useful. And also you have to see the compiler generated instructions. If they are not efficient, don't go for bit fields. Instead of that, you can use your own primitive data types like integers, and you do your own logic, write your own logic to access the individual bits of the register. Okay, if you want to transfer the data across network or across another peripherals whose NDNS is unknown or different, don't use this. And to avoid padding, always keep the members in descending order of size. Not only for bit fields, in general we should prefer to keep the members in descending order of their size, so that the paddings will be avoided. Okay, these are some guidelines. And thanks for watching. So we will end our lecture today, and please share this video to your friends and colleagues who are interested in learning advanced concept. We will continue in the next lecture. Thanks for watching. Bye.